Okay, so in this video, I'm going to show you how to get started on your effect pedal design. This video won't go all the way to the end, but we will get into the circuit board layout a little bit. But then there will be a second video for like laying out the circuit board and all that. And then there will just be a lot of time provided and resources. I'm going to say this in the video as well, but I'm saying this to you guys right now. I have a broken toe. So like, I don't want to walk around all day. Okay, I'm not going to, like, in the video, tell a bunch of stories. Okay, that's really boring. But I need you to come to me when you're stuck. Okay? I will still move, but I'm not going to move as much. Okay? I can still walk, but I'm not going to move as much because I want to keep the toes immobile, especially in these earlier days, because it would just happen on Monday night. So. So just FYI, today and probably on Monday, you might be less ambulatory. Eventually, I'll be walking around just fine. Okay. Okay, so I'm going to start from scratch, and the first part is to get this file. And so I'll show you how you get that file if you don't have it. So we're going to go over here, and the URL is tiny.cc/pedals, but with a capital P. So capital P-E-D-A-L-S. And if you go there, okay, Zane, you can do this right now. Yeah. Okay, and then you'll go up here. Do you guys see the download button? This is, I don't know how many times I have to remind people that there's a download button, but there's a download button. If you haven't downloaded it, you click it, you download the file, okay? All right. This is a Mac, so unfortunately I can't show you exactly how it works out on other computers, on a Windows computer. So I'm going to close this here, but I will show you on a Mac, if you just click open the zip file, it'll just open it and extract it as like a regular folder. On a Windows computer, when you get to this screen, it won't look exactly like this. It's still a zip file. It just opened up the zip file. In order to use it, you have to extract it, and there'll be a button somewhere over here on a Windows computer that says extract all. You have to hit extract all in order to extract it. And then once it's extracted, then you can open it. You'll get this file, and you'll have a board file. The board file will look like an insane mess. Okay. All right. Okay, but we're going to start in the schematic. And as crazy as it looks, this is intentionally designed to make it as simple as possible to design an effect pedal from scratch. And so this is what I talked about last time, but I'm just going to go over for the sake of the video and for the sake of those of you who weren't here. What you're going to do to start is to find the module or modules that your pedal is going to be based off, what your prototype is going to be based off, and you're just going to move them so that you can use them. So I'm going to do a couple of different examples. So the first example I'm going to do is a more complex one. Actually, let's do a simple one first. Say I just wanted to do just hard clipping, and that was like my only module. So I would go here and shoot, I can't see on the screen all the buttons there. They are. Okay, I'm going to go over here. I'm going to group them. The group function's right there. Okay, I'm going to group them. I'm going to go to the move function, right click, move, group, and then I'm going to move it up here. And then that would be, if I'm just using that one module, I'd be done. If I was doing something a little more complex, say I was doing a reverb. Okay? A reverb involves the reverb and ability to mix in the dry signal, okay, with the unreverbed signal. So I'm going to take this and move it. So if I was doing a reverb, okay, but then I would also need one of these miscellaneous circuits. But I'm going to talk about these miscellaneous circuits later. So for now, I'm just going to stick this up here, like way up here, to kind of separate it. And then if you're doing something with an LFO, so say I was doing a phaser. Phaser is here. So right there it says phaser. And right there, it says phaser LFO. So I'm going to grab both those circuits. when I do so, I think I'm going to accidentally grab some extra stuff because I didn't give quite the right spacing. Move. Yeah, I'll have to delete a few things, but it's fine. So I'm going to move that, move this like over here, and really give its own spot. Okay, you only have to do, yours here. I'm going to delete that stuff that moved with it. And then all of the other modules, and this is where we kind of mostly ended for most of us last time, all of the other modules over here can be deleted. So starting right there and moving over can go away and leaving me with just the things that say, don't delete these are part of the template, to the miscellaneous circuits that you may or may not need. Okay? And so I'm going to pause there. I want to check in with you guys in the room, like where you're at. And then I'm going to talk about these miscellaneous circuits, when you need them, when you don't need them. Okay, so I want to talk about the miscellaneous circuits, what they do in very short, and when you need them and when you don't. Okay? All right, so let's zoom in here. So first, this is a charge pump. It basically what it does is it takes the 9 volts, the positive 9 volts, and turns it into negative 9 volts, so you can have positive and negative power source. There's only some circuits that need it, and you can actually adapt. In fact, I do this all the time in my actual pedals that I sell. I adapt this so that my circuits can, even though you can only plug in 9 volts, which is the industry standard, they run essentially on 18, because plus 9 and negative 9 are 18. And that makes them run more like professional studio gear than like, battery-powered effect pedals, which can make them sound better in certain situations, or just at least different. The only reason why I left this here is if you wanted to build in a microphone preamp so that you could plug a microphone in instead of a guitar, that microphone preamp chip needs positive and negative power. So if you're going to build in a microphone preamp into the circuit, then you would need this. Otherwise, which I don't think is anyone in this room, you can delete this thing. Okay, we're just gonna delete it. Okay. All right, the 5-volt regulator takes in 9 volts, and guess what it outputs? You guys with me? The next one, the 9-volt regulator takes in your 9-volt power supply and outputs what? How many volts? 5. It can intake 18 volts and output 5. It regulates it at 5 volts. The circuits that require 5 volts are the delay and the reverb, but I'm pretty sure I built this circuit into both of them. Do you guys hear me? Like this circuit, something like it probably exists in your delay or reverb if that's what you grabbed. And if it already exists, you don't need it. It's already there. Definitely in the reverb, and I'm pretty sure in the delay too. Okay. Okay, so we can delete that one. Okay. All right. I'm going to talk about this one later. Okay. Let's talk about this one. The buffer boost. So here's a buffer. There's 2 of them. There's an op-amp buffer, and there is a transistor buffer. Now, here's what I'm going to tell you. This is one where I'm going to need to individually coach you on if you need it or not. If you use it when you don't need it, it actually is not a big deal, except for the fact that now you have a more complex circuit to build. So like that's the only reason not to. It won't like make it not work. It's just that some circuits don't play well when you plug a passive guitar directly into them. They don't work the way they should, and so they need a buffer in between. And some circuits, they're fine. They're fine on their own if you plug the guitar straight into. And so that'll be something that I have to coach you in. The basic term that we use is what the input impedance is, and that means how much current is needed to drive that input, how much current is needed because of how much impedance or resistance it has. If it's a really low resistance, it needs more current, and so therefore it needs more power. And so electric guitars, they can't do that. So I'm going to coach you individually, but here's where I'm going to give you a generic one for the sake of the video. Can you guys pause your conversations? Thank you. For the sake of the video, I'm going to say generically, but I want you to get coached individually. Generically speaking, if you have anything like a delay, reverb, modulation, anything like that, you're going to need a buffer just to split the dry signal out. Okay? If you have anything that is like not like a direct connect, usually it's like distortions and fuzzes and soft clipping. Those things usually can directly connect into because they're designed specifically for guitar from the beginning, and so they've already been okay to plug directly into. And then it's kind of like some of the other ones, it depends, okay? And there'll be choices around that. But anything that's designed to like drive a guitar signal is probably fine to just plug straight into because it's been designed for that. And anything that's like splits the signal, you're going to want a buffer before you split it, okay? And then typically most EQs are not designed to be plugged straight into, so if it's an EQ, you probably want a buffer first. But now I'm going to individually coach you, okay? All right, now, if you do need a buffer, there's a choice between a transistor buffer and an op-amp buffer. And I'm going to kind of give you some small coaching in this, but not a lot. Most of you just need an op-amp buffer. If the rest of your circuit has op-amps, just use an op-amp buffer. It's going to be the easiest to integrate into the rest of the circuit. If the rest of the circuit has a transistor and you want a transistor buffer and it's a bunch of transistors, use a transistor buffer. That's just basically my coaching. Okay, so Isis is going to stop talking. I'm going to take this here, and I actually need it, I think, in 2 of my examples. I don't need it for this hard clipping one. Oh yeah, I definitely don't need that. I do need it for a reverb because it's splitting the signal out, so I do need it there. So I'm going to kind of actually line up those outputs and inputs there just for convenience. And I do need it for this phaser for the same exact reason. Okay? All right. Now, let's go to the rest of the circuits. Okay? So I'm going to delete my buffers. So if you don't need a buffer, or if you've already moved yours up, you can delete the other buffers. This transistor boost right here, sorry, that's not, this right here is a transistor boost. This is only if you wanted to like add in a boost into your signal, but you would have had a module that you put in your thing that was a boost. And if you don't have that module, just delete it. Okay. All right, now let's go down to the bottom here. All right, do you see this one? What does it say? What dry chorus? If you're doing the chorus, you need it. If you're not doing the chorus, you don't need it. Okay? It's that simple. Okay. And if you're doing the chorus, I can like coach you on how to connect it. In fact, if you're doing the chorus, you only need the chorus stuff and this and nothing else. Okay? All right, we're getting close to the end here of the miscellaneous. Hopefully you've been deleting along the way. So now I'm going to talk about these gain and mixing circuits. So here I have a blend circuit, blend and level circuit. Here I have clean gain, one that says inverting and one that says non-inverting, and then down here I have mixer. Okay. In general, these clean gain things are only if you had a really specific need to add gain somewhere, and I don't think any of you were asking for that. So if you're like, no, I need some volume increase in my pedal, I just need to be able to increase the volume, then sure, we can put one of these circuits in. But unless that's you, like something that you wanted to do, just delete these 2. Delete the clean gain, which leaves 2 circuits that I want to talk about, spend a little time talking about. I'm going to move them together so I can zoom in, make them bigger on the screen. Okay. All right. You guys ready to learn about these 2 circuits? Okay. The difference between these 2 circuits. This mixer circuit allows you to mix in as many different signals you want. You could technically have your, I mean, you wouldn't do this because it'd be too complex for your first build. But if you were like, hey, I want an overdrive and a distortion and a delay and a whatever, and a what, and just keep listing like 7 things, and then I just want a knob to blend them all in together. Like, here's a knob to blend in my reverb, here's a knob to blend in my distortion, here's a knob to blend it, like mix it all together. You could do this with this one thing. Right here I'm showing 3 inputs, but you could easily repeat that and have 12. Like, it's possible. Okay? Don't do that, but I'm just saying you could. This blend circuit is when you want a single knob to go from one thing and blend it all the way over to another thing. Okay? An example of where you would definitely want this is if you did it for the compressor. You definitely want to go no compression at all the way up to only compression. Okay? There are other times where there might be a reason for it. So like if you had an echo, you could go from no echo to only echo, but that would only be if you were using it in a specific scenario where it's like an effects loop and an amp. Unless you know you need only echo, then I would just not use the blend version. Okay, and so yeah, so a phaser, a chorus, that would be good to have a whole full blend from one to the other. Those kind of things would be very useful, but. Delay and reverb, I generally think a mixer is better for most of you, especially when you're starting out. It's going to be simpler. Okay? Okay, I'm going to stop and make sure that everyone who has a mixer knows what they need to do. Okay, I'm going to move this mixer to my reverb because I determined that this is going to be necessary here. And I'm going to move this blender to my phaser over here. And actually, I'm going to move this LFO to the bottom because that'll be easier to work with. Move. Okay. Okay, I need conversations to pause in the room. We got several conversations. I'm showing you the next steps. Thank you. Okay. All right, I'm going to do different examples for the next steps, but now our next steps are to connect inputs and outputs, to connect circuits together. And the other thing that I'll talk about is something I talked about last time, which is making sure to update your values. But I'll probably get to that after talking about all the details about connecting things together. Okay. Okay, so I'm going to start very, very basic. Can you guys look up here? Okay. So this is a hard clipping circuit. In it, it's got a gain control. And, oh, I didn't label that one. This is a compression control. Okay. So gain control and a compression control. If you wanted to be simple, so this is our compression control. If you wanted to be simple and you're like, I don't really need the compression control at all, you can delete it. I could delete this control right here, this potentiometer, and just wire these diodes straight up. And that would be equivalent to just turning the compression control all the way up. This is kind of a standard way how these circuits work anyway. Okay? But that's your choice whether or not you want it or not. Okay? Now, when it comes to input and output, it depends on how the circuit works, what you will need. And I'm just really realizing now I should have told you that sometimes you need an output buffer. But we'll get to that. So let's talk about the input. Can you guys look up here? So do you see where it says in on here? So go to your thing that's your first input, whether that's a buffer, whether that's the hard clipping, whether that's the fuzz, whatever's first. I'm going to move this word input further out because we're going to need to add a little bit of circuitry here. Okay. What you're going to do is make sure that if I follow this line to the first thing, you see how I have this straight line going from the input to the first object where it stops, that line stops. There should be 2 things in there, and sometimes they're already there, and sometimes they're not. Okay? There should be a resistor and then a capacitor, like this. So this one only had the capacitor, so I had to add in the resistor. Okay. Most of them should have a capacitor to start. I've like built that in for you, but not all of them have that resistor. The value of that resistor can vary based on the needs of the circuit, but if you just added one because it wasn't there, I would just make it 1K. That's a good standard thing where it's not going to have an impact on your sound, but it will accomplish the goal that we need it to. Okay. Okay. Next, we'll move that a little closer. We need a second resistor, and that resistor is going to look like this. Come on, copy. I'm going to make it clear where it is. Okay. And for its value, just to give a nice default value that most pedals would be just fine with, we're going to do 2.2 capital M. That's 2.2 mega or 2.2 million ohms. The purpose of this resistor, it's called a drop-down resistor. What is that resistor connected to on its bottom? Ground. Ground is 0 volts. And what happens when you turn the pedal off and turn it on is that this spot right here, if it's not connected to ground, is free to float to whatever voltage just the atmosphere and the lights and the ground, the wires and the walls are just like causing it to happen. And if that happens, that means that there's a little bit of voltage on your input. And if you immediately turn on the pedal with some little voltage on the input, that voltage will get to the output and you'll hear a pop when you turn it on. Okay? And so by dropping it down to 0, that will help it stay at 0 when your pedal's off and there's nothing connected. Okay? And so that's for the input. For the output, it depends on what's here. And I just realized, for those of you guys who had hard clipping, I just realized that we're going to need to add a buffer, an output buffer, if that's the only module you have. Just because this, you don't want to just go straight out with. I guess you technically could, but it's not a great plan. So if you have the op-amp buffer, which I have one right there that I can copy over. And if you didn't, if you deleted it, you might have to do undo to get it back. Okay, my apologies on not doing that. So for this hard clipping, if that's all you have, then you should put a buffer there. Okay. And then so now I want you to go to your last output, whichever one was last for you. So if you have a mixer or a blender, that's last. If you just have this hard clipping, then you'll want to put a buffer. That'll be last. Okay, and so on. Okay. For your last output, so this op-amp buffer right here. Our last output for me is this op-amp buffer. If I was doing a reverb, the last output would be from the mixer. If I was doing the phaser, it's from this blend plus level circuit, that output, which apparently that got deleted, but it should say out there. That's my last output. Okay, here's what you need to add to the last output. Okay, you guys ready? The first thing you need is a capacitor. Now, you're welcome to use a capacitor from your existing circuit. However, the one you should be looking for is one that looks like this, like an aluminum electrolytic. Okay? Basically, anything that's 1U or higher, 1U or higher, so nothing that's an N or a P. So 1U or higher, we could put here. If you have one that has a positive and negative end like this one, put the positive end next to your output and the negative end going out. If you had one that doesn't have a positive negative, it doesn't matter like which way it goes. And so you want to find one that's 1U or higher. If you don't have one that's 1U or higher, I can show you how to find that capacitor. But that's our first objective. In fact, actually, I'm going to quickly, for the sake of the video, just be like, if you don't have something that's 1U or higher, here's how you find it. We click the add part, I'm going to go quick because the video, you can always pause me. I'm going to scroll down to where it says RCL. CL. Okay. So let's use this one. And then I'm going to go C-pole US, that's capacitor polarized US. And then I'm going to find the one that's E2-5 right here. Remember, you can like change the size of these things. So if you can't see it, you can just drag it out. E2-5, and that'll be what I can use right there. Okay. And that'll work perfectly for this purpose. Okay. But if you already have something that's 1U or higher, just use that. Just copy it over. Don't even have to go find a part. Next thing we're going to do is we're going to copy a resistor. Any resistor, we'll change its value in a second. And we're going to put that resistor like so. And then we'll do it again and do it like so. Okay. And then this resistor that's facing down, just like on the input, we're going to find a ground symbol. There's a ground symbol. And we're going to ground it at the bottom. We're going to connect these together. Okay. And then these values for these resistors really do matter. So don't just leave them as they are, because you don't want to put in the wrong value. For the one that actually goes to the output, that goes through this straight line, just change it to 1K. 1K is a good output impedance. And the one that goes straight down, well, what I have right here is actually a pretty reasonable value. 100K, okay, will be just fine. And so what this does is the capacitor blocks DC signal, meaning that some outputs might be at like 5 volts. Well, if you went from 0 volts to 5 volts instantaneously, you might actually break your amp. If you did it a lot. Like, it would be a very obnoxiously loud pop. And so we need to block that. And so that's what this does. And then the resistor after it, connecting to ground, makes it, instead of being 5 volts or whatever voltage, it's now 0. Okay? And then this resistor, and the reason why there's a resistor on both ends, it slows down the amount of current that can happen in one moment. So even if there is still a little bit of voltage, that voltage doesn't travel as fast because it doesn't push as much current. So it doesn't make as much of a pop. And so this is all about making it so that when you turn on and off your pedal, it doesn't make your speaker make a loud pop. Okay? That's what it's for. Okay. I'm going to give you one set more of instructions for this. It's very simple, but you have to see it. You guys looking up here? Okay. All right. And I apologize. I don't know why it's labeled this way. I mean, I do, I guess, because it's a... Okay, see where it says in and out here? Right now I'm in the do not delete section. You guys see where it says in and out? Okay, so there's a thing called return and send and in and out. They basically kind of mean the same thing, just on different levels. So this pin right here that has nothing going for it, are you guys watching? This pin that has nothing going for it, do you see how it's lined up with the in? So I'm going to go and put it here. It's my in. It's my in pin. And if you go down here and you see the one that's lined up with the out, it's called the return. Okay? It's going to go line up with my out. So I'm going to go put it there. And it should make sure that it's all wired up like that. Okay? And then once I've done that, now I have signal that will connect into my board and come out from it. So I just need to make sure I now can focus on the inside of my board. And that's what we'll get to next. Okay, for this next part, I'll just talk about, hey, we have separate modules. We might need to stitch them together. So we have our output connected or input, but we need the whole thing stitched together. So I've tried to make it as easy as possible. So when I have 2 separate modules, here's the output of one and the input of the other. All I need to make sure that's between the 2 modules is a capacitor to block the voltage of one from the other so that they operate independently. But that's probably built in already. Do you see the capacitor right here? So I don't need to add one. There's one there. All I need to do is wire the output of this to the input of that. And when it says, do you want to connect these? Yeah. And then they're connected. This is a complete and functional schematic. if I were to do this for the reverb, okay, I'm going to have to talk a little bit about how mixers work. But here's the output here, here's the input. There is a capacitor built inside of the reverb brick. And so I just need to go the output of the buffer straight into here. Okay. Now, do you guys, whoever has a mixer, anyone got a mixer? You guys got a mixer? Don't connect these ones yet, because I have to specifically coach you how to do these. Okay? But you can connect the reverb from the buffer. Okay? So a mixer I'm going to coach in a second. Who's got the blend and level circuit? Okay. Here's what you need here. On the blend and level circuit, you want your in2 to be the effect. And you want to make sure that there is a capacitor between the output of this effect. So here's my phaser. I want to put a capacitor between these two. And you want it, like the last time, to be like a capacitor that's at least 1U. Okay? So I'm going to go find that same capacitor I used on the output, click it. I'm going to come here. I'm going to stick it there. In this case, it doesn't typically matter which direction it faces, although sometimes it can. So I'll try to help guide you through that individually, but in many cases it doesn't matter. It kind of matters on the delay. If you use, on the delay it would matter, but only if you're using the blend circuit. So anyway. Okay. So that my effect is going to in2. Okay. All right, now, your attention please. Okay, your attention please. Okay. Once you've stitched those things together, again, I haven't showed you how to totally do it with a blend circuit, just like the first part, or a mixer circuit, just the first part. You're really close. Some of you may even be done, but then there's some questions that you have to ask. Right now, none, how many? None of these pedals have a volume knob unless you have the blend circuit that has a level knob built in. Then it does have a volume knob. And so you have to ask yourself, do I need a volume knob? Some effects don't, some effects do. What effects do you think need a volume knob? Distortion, because it gets so loud, you want to pull the volume down. Okay? Those ones need a volume knob. Just a compressor would need a volume knob, but if you got the blend plus level, it's got some volume knob built in, so you don't need to add it. So some of us, we need to add in a volume knob. So I'm going to show you how to do that. So that would be Noah and Brecken and Ella and Oliver's team. You guys all need a volume knob. You have a volume knob built into the fuzz. It's already there. So, okay. We'll show you how to do that. So here we go. First thing you need to decide is where will your volume knob be. So I'm going to zoom in on this section here that says Effect Pedal Template Parts, Do Not Delete. And now I have to talk to you about the locations of things. So here's a pedal. Can you guys see it? Okay. How many knobs does this pedal going to have? It's going to have 4. The default pre-drilled enclosures, which won't have a graphic on them, but the default pre-drilled ones where you don't have to do any drilling will all have 4 knobs, or 4 places for knobs or switches, 4 sets of controls. This, you are not required to do 4. But does it actually make your job a little bit easier when you go to build it if you do exactly 4? Yeah, it will make your job a little bit easier when you go to build it if it's all pre-drilled for you. Okay? So it would be super, super helpful if you just, if you just had the 4. But regardless of where you're at, if you want to add a volume knob, you need to decide where that volume knob is going to go. And I've pre-made some locations for you to pick from. What do you think TL stands for? Top left. And TR? Top right. And BL? Bottom left. And BR? Bottom right. And so that's saying on your pedal, where do you want your volume knob to be? Okay. And so if you're adding a volume knob, right now you have to make a decision. Where's it going to go? So make that decision, and then I'll show you what to do with it. For those of you who need to add a volume control, I'm going to show you how to do it. So first, grab your control. So if it's top left, grab it, and then we're going to move it towards the output here, and we're actually going to replace one of our resistors. I'll show you how this works. So what I'm going to do is I'm going to rotate this until it looks like this. Do you see the small arrow, how it points up? Okay, that's what I want. Then what I'm going to do is I'm going to take this resistor right here. See the 100K resistor that goes to ground? I'm going to delete it. I'm also going to delete the connection between the capacitor and the output resistor. And then what I'm going to do, I'm going to move some stuff around to make this happen, is I'm going to do this. And I'll wire that in here. So now what it has to do is it has to go through this capacitor, down the potentiometer, and then out. And so by going here, if I turn the potentiometer down towards 0, I get no signal. And if I turn it all the way up, I get the full volume, the loudest possible signal. I've created a volume knob. This is called a passive attenuator. It's a very simple circuit, just one part. Okay? But we need to choose its value. So you guys with me? Right now, its value is top left. That's not a value, that's its location. For these volume knobs, the sort of standard value that is often used is A100K. It's often used. I'm going to ask you to make it A50K. Okay? You could use A100K. Depending on what your capacitor is, you might even be able to get away with A10K. The smaller the value, the less it will impact how, because cables impact sound. So if you have a really long cable, sometimes that can impact sound more than a short cable. But if this value is smaller, the less impact it'll have on whatever small impact your cable has. So certain circuits, like if you have an op-amp buffer, you could make this A10K. Not a problem. If you've got the fuzz circuit, the fuzz distortion one, I do A100K because it can't push much. Okay, Jacob, if you looked at yours said A500K for your volume knob. So depending on how the circuit works out, will greatly change how it sounds. Okay. Okay, we have 2 more steps left. One is only necessary if you have an op-amp, which most circuits do. So if you have an op-amp, this step is necessary. And that is, when we were combining modules and such, the op-amp chip is just its own individual thing from that module, and it's not connected to the other op-amp chip from the other module. And that may mean that suddenly we have way more actual physical chips than we need, because an op-amp chip can actually contain up to 4 op-amps. So I might have 4 schematic signals, but it's only one part. And that makes it way simpler to build your circuit if you can do that. But right now, because we've been combining things from multiple things, you might have 4 op-amps and literally have 4 chips. That makes it more complicated to build your thing. And so that is why down here at the bottom, you see where it says op-amp ICs. And it says, if you just need a single, use this one. If you need a dual, use these 2. If you need a quad, use these. And so here's where I'm going to do some coaching here to help you figure out what you need to do. So I'm just going to do some individual examples and then some coaching here. So this one, you guys look at the screen. How many op-amps do you see in this schematic? Look at the screen. How many op-amps? How many? 2. 1, 2. Okay. Now, you could make them both singles in the hard clipping section, because there is particularly, if you like the sound of this op-amp, then you don't want to change it. You'll have to have 2 singles. Or you could delete them both. Can you guys look up here? You could delete them both and replace them with the dual op-amp. So I could just move this over. But actually what I typically recommend is to group it, group the two together, copy and paste as one. So you have this one entity. Don't copy and paste them as individual pieces. That makes two entities. And I'm just going to drag this one in here. I'm going to drag that one in there. Now if I do this, do you see this it's compensation capacitor? Do you see how it's connected to nothing now? There's no pins anymore. If you decided to go with dual, you would just delete that because it doesn't have any pins. Only the single one has the pins for that. Okay? But that would be your call. How many op amps are up here in this reverb? You guys looking? How many op amps? 2. So I'm going to do the same thing. This time, because I know, I'll copy and paste again. Copy, paste, because I got so many examples to do. Stick it up here. Now I want you to see what happens here. Those of you guys have op amps, you need to pay attention to this. So I'm going to delete these 2. But look at this one. Do you see where the minus is? It's up top and not on. So if you've got a mixer, you can't just drag this in as is. You have to rotate it and then mirror it so that the minus is on top. Now that the minus is on top, now it's a perfect match, then I can delete it. So here I can drag this in here. Uh-oh. Do you guys see a problem here? Do you see the extra pins this has? So what I'm going to do is I'm going to make it so that my extra pins don't touch. So I'd like drag that down so it didn't touch. Okay. I'm going to fix this one here. I'm going to delete that and drag in the new one. But then what these pins are power and ground. So here I'm going to copy this. I'm going to go up to +9 volts and paste it there. And I'm going to find a ground symbol. There's one. And I'm going to paste it there. And if I'm really OCD, I'm like, oh, I don't like lines going through lines. I'm going to go like that. Okay. So that it looks better. So there's my input. And now these 2 chips are 1 chip on the circuit board. Now let me show you something that's super complex. How many op amps are in this one? You guys looking? How many op amps do you see? We can count. There are 8. So I could do 2 quad op amps with this. Okay. What I'm going to tell you though is if you are doing the phaser, which I don't know if anyone is doing the phaser. If you were to specifically do the phaser, there's a reason why I grabbed this one. You would not actually want to do anything except to replace this input and that output with a dual. Everything else is fine as is. Okay. For most other things, you would want to like consolidate and be like, okay, let's put 2 quads. But the phaser in specific, this already is a quad, and this one is a dual, and they need to do their jobs separately. And then so if you add this, this is what you need to change into a dual. I'm not going to do that here on screen, but you need to change that into a dual. Okay. But other than that, you would consolidate. Okay. All right, now there's one last thing. This is for everybody. Okay. If you haven't, if you're watching the video and you haven't caught up to this spot, I would make sure you finish everything, pause it, that kind of stuff. But I'm going to show you the last thing as class runs out. Okay? And that is, what do you want where? What controls do you want where on your pedal? So first you have to like count up what all your controls are and decide where they go. And then I'm going to show you how you do it. You guys with me? So I'm going to go look at this first example here where we already placed our volume control. Do you see it? We placed that already. But look around. I should have, and I didn't do this perfectly, but I tried to, with red labeling, label any other controls. So this has a gain control and a compression control. If I go up here, do you see some controls? We have decay time. We have speed. Okay, like what controls are what? And I just realized we have to talk about the mixer, dang it. So that'll be our addendum for those who have it, blender or mixer. And you're just going to drag them in. So if I want my bottom left control to be my compression control, what I'm going to do, if you guys will look up here, is I'm going to take that bottom left control. I'm going to make it look exactly like the other one. So did these look identical now, this compression control and that one? Like the arrows pointing the same way, all that? And then what I need to do is go and change the value so that matches, C10K, because this is what this was, C10K. And then I'll just delete this one. Oops, I thought I was deleting it. Delete this one and drag in the other one in its spot. And the reason why we do this is I've pre-placed that potentiometer in exactly the right spot it would need to go to fit into this template. And by just using the one that I've pre-placed, then you don't have to worry about like lining it up and flipping it over and doing all that work. It's already built together in that template. Okay. All right, so the last thing, if you have a mixer or blender, there is one more thing you have to do. If you don't have a mixer or blender, once you replace those parts, you basically are done. There might be a few more things to delete, but you're basically done. Okay. If you have a mixer or blender, let me show you how that works. All right, so I'm going to start over here. You guys are doing the mixer. Okay. So first, you're in one. You just want to be your after your buffer. So here's my buffer. So after it is right here. This is my output of my buffer. And all I'm going to do is I'm going to click this. I'm going to drag it around and go to in1. Okay. Okay. All right. And then for in2, we want to control the volume of the delay or the reverb or whatever thing that we're mixing in. And so we're going to grab the control you want to be your reverb knob or your delay knob or how loud your delay is. So you decide whether that's top right, bottom right, whatever it is, top left. And then you're going to do what I showed people to do with the volume controls. So if you guys look up here, I'm going to show you really quickly here. You would just essentially stick it right there. And then this gets wired to in2. That gets wired to the output of my reverb or delay or whatever that I'm mixing in. Okay. And then the few other things that you'll need to do is there's some values you'll need to change. So I would call this B10K. For the sake of simplicity, I'm going to go 2.2K, 2.2K, 1K, like that. And those values should do a good job. And in this case, I don't need in3. There's no in3, and so I'll just delete that and its resistor. Okay. And I'm going to pause the video there.